We have lead 2 sulfate.
Lead 2 sulfate, it means it has a formula. Do you remember the formula?
Yes, we have PPSO4.
Good. Let's fly to see this. Oh, salt solution and the solution. What I want from this, I want to write
the solution and the solution symbols and the equation.
Good. The equation here must begin with both. Now, salt solution plus mean 1, it means lead acetate. You remember? Do you think what happened now will give?
Give white PPT of what? Of another compound of lead acetate.
Solution. Good. It's good to say all of them, but you must concentrate for this reaction. Na2SO4 in aqueous solution plus lead acetate CH3COO all by 2 PP. This is aqueous one. Product will be
2 molecules of CH3COONA sodium acetate and in aqueous solution, and we have PPSO4. It is lead sulfate, lead 2 sulfate.
It's good to say that, but tell me what is the important substance here or important solution? I don't understand one. What is the most important one?
It's lead sulfate here.
But I say it's a solution. Do you think it's a solution?
No, it is solid state or precipitate.
It's good to say all of them. Now, what about to get this?
Second, we have analytical group.
Analytical group? Do you think we travel to the other part of the lesson? This is anions? Do you think it's anions?
No, they are called cations.
I don't understand this well, but tell me what is the cations after this group? Look at this. Oh, qualitative analysis of the cations. I think this word, the cation, in the whole world, China, Egypt, everywhere, it means
the positive ions of the experiment show in this package may pose the certain path or the certain part of what? Of the compounds.
It's good to say that. You must contain the positive charge. We get different tubes, as you see for this video, identify the common cations, different one, analyzed, and what cation is present in the sample.
We can carry out the flame test, and we have some kind of this flame testing chemically change to observe the products and the following parts.
Expected the observation to write what your conclusion. The first one, aluminium. What do you see?
Aluminium ion is colorless cation. Sodium hydroxide solution of aqueous ammonia can be used for this testing.
Add sodium hydroxide solution. We will see formation of white precipitate of aluminium. Aluminium hydroxide, by the excess of sodium hydroxide, will give me
the white precipitate.
The white precipitate especially and disappear by excess of
NaOH.
It's good to say that because formation of aluminium hydroxide. Now you have
aqueous ammonia is
used for this reaction and we add aluminium hydroxide. This reaction, excess of the ammonia is added. By the same and last equation, formation of the color is
white color. We have the reaction of Al positive 3 and we have the equation Al positive 3 with NaOH and the excess of NaOH. We have the precipitate or white precipitate of this reaction. It can be identified. Another one of this test.
This test about the calcium. Directly we have holder and we try to heat it on the flame. From the time to time, I want to know what happened. I added to the water to be solution and the further by sodium sulfate. White precipitate will be formed. But this reaction of the calcium sulfate is insolubly water, not soluble. So the reaction here is not complete.
So the calcium positive 2 aqueous solution plus SO4 negative 2 aqueous solution give us calcium sulfate in the precipitate.
What about the copper 2 ion? It's a copper 2 ions blue. Blue for dry test. Look at this. When you heat the copper for this flame, give you this wonderful blue color. Try to close to green. Now, when you add more of sodium hydroxide to the solution, you can see the color is changed into
green color or green blue color.
It's good, but we say gelatinous one. The equation?
In Cu positive 2 aqueous solution, we have NaOH that give us copper hydroxide solution.
What happens if you add more ammonia? The aqueous solution here, the color is changed into
blue color.
Good. This it means we have a copper. Excess of ammonia is added. For this case, the precipitate will dissolve. So, when you make treatment for this solution for the blue color and add more, will be more dark. Equation?
We have the copper and NH3 aqueous solution, and we have the copper hydroxide soluble
with ammonia, and they give this color and they change it into different color. The other one for iron 2 anion. Iron 2 add sodium hydroxide solution containing iron 2 ion. See, what is the color for this case?
This color is green color.
Is not completely green. It's whitish one. We say green whitish. So precipitate will not dissolve. Do you think why? Like aluminium. Now, what happens when you add more ammonia?
In the color is change into black color.
So Fe plus NH3 directly iron hydroxide and ammonia aqueous. What about the third one?
We have iron 3 and the ion is a pale yellow ion. So the sodium hydroxide solution is added to the solution containing the iron 3. What is the color here?
The color is changed to the brown. As you see, we can say reddish brown. So iron 3 hydroxide, a special color by the excess of the alkaline solution, the precipitate also not dissolve. But when you add ammonia for this solution, you cannot this color start to be changed and concentrated. Directly we say
Fe3 aqueous solution with ammonia give us iron hydroxide 3, and we have the ammonium solution that's appear. And we have another one, the zinc ion is colorless ion. What will happen here?
For this equation, add sodium hydroxide as usual, as we do it all time, and we see the changing for the color. It's a gelatinous one, so zinc hydroxide is formed. By shaking from time to time and the excess of solution added to this, do you see dissolve or not dissolve?
This is not dissolved.
No, it's dissolved. Be careful and look.
Yes, it is soluble. Zincate or zincate here in this reaction. So the equation, it will be ZnOH by 2 plus OH aqueous solution. We have ZnOH by 4. This is the solution of this compound of zinc hydroxide.
Add ammonia to zinc hydroxide and tell me what happened and what is the color now.
What is the color is what? The color is white, gelatinous one.
The excess aqueous ammonia is added to this from time to time. Directly the color will
disappear
and dissolve this, and the color is not here. You have now colorless. Equation
is ZnOH by 2 plus NH3 aqueous solution. Zn give us ZnNH3 by 4. This is the solution of the compound.
What about ammonium? Oh, ammonium, it's good. What happens if you add sodium hydroxide to ammonia? Look at this. The color gas will start to be evolved. But I don't know what this gas. But be careful for litmus paper. The color of this red litmus paper directly it changes into blue. This tell me the gas is
NH3.
This is, it means alkaline gas has a colorless, which it changed into blue. Blue with what? With litmus paper. What about this? It's about
the cation. This group are what are precipitated in the form of sulphide acidic medium by dissolving the salt in water.
It's good to say all of this. What about this? You must add dilute hydrochloric acid. This hydrochloric acid to it make a solution is acidic solution. Now, What do you see after that?
We have passing the hydrogen sulfide gas through it, and we have copper plus 2 ions or radical that in one form this group.
These groups about copper 2 cation. Catch it and concentrate it to understand what we talk about. Copper 2 cation. Catch this now.
So here we have the copper 2 cation. We have some reaction here that's happened to make what? To make detection of the copper ion.
So, when you add slowly this salt make different reaction and the color blue. As you see, it means you have copper cation. When you start to dissolve for this reaction, be sure copper cation the strongest one. Fly to this. Copper 2.
Copper 2 salt solution plus what? Group reagent HCl plus H2S. This is the reagent of this group. It's black PPT.
Good. Tell me, what is meant by group reagent?
This is the reagent here, HCl plus H2S, hydrogen chloride, and in aqueous solution, and H2S, hydrogen sulfide gas in black PPT.
It's good. Do you think what happened after that? From copper 2 sulfide is formed. Do you think that's only? Sure, it's not. Look at this.
Soluble, this is formed. Copper 2 sulfide is formed soluble in the hot nitric acid.
It's good to say that. My dear students, don't forget. What about the dissolving solubility for any compound we make it? Talk about solubility. Catch this one. Equation. Catch it now.
So the equation here, we have copper sulfate aqueous solution, and we have H2S gaseous state. And remember this, the state of each one of the components here of reactant and the product. What are the products here?
Product directly, you know it, and everyone know it now. The first one about sulfuric acid, H2SO4 in aqueous state. The result important one for this solid state is
copper sulfate.
Copper sulfide here, it's important for indicator the sulfide group. My dear, don't forget CuS, and it has a special color. The color is
black color.
Good. What about it? To catch this now, they are precipitated as hydroxide using ammonium. Tell.
Hydroxide, if they are not mixed with other cations.
Cations here, it means what? It means positive, so cannot be mixed. Now, cations here to be studied, you must know.
We have aluminum, Al, positive 3.
Good to say, positive 3. The second one,
iron 2, Fe.
Only?
No, we have positive 2.
Third one,
we have iron 3.
Only?
No, we have positive 3.
So, we did use all cations
contains positive ion, positive 2 or positive 3.
Divalent or trivalent. Easy and important.
The main experiment here is salt solution plus ammonium hydroxide. This is the group reagent.
Oh, we have group reagent also here. Tell me it again, I don't understand what you tell me about.
Here we have the group reagent. It means mixing between these two compounds salt solution that contains any one of these cations, and we have the ammonium hydroxide. This is called the group reagent.
You have cation. This cation about aluminium. This aluminium, it has a symbol
Al positive 3.
It's good to say that. Do you think, what about the reaction for aluminium? Tell me now.
We have the equations here. So the equation, reaction with group reagent. So
good. Group reagent, start with this.
Al2SO4 by 3 aqueous solution. It must be aqueous solution in the presence of NH4OH ammonium hydroxide aqueous solution.
No, this equation is not right. You must say 6 molecules of ammonium hydroxide. My dear colleague, tell me, what is the result now?
So the result here, we have 3NH4 by 2SO4 in aqueous solution. It means ammonium sulfate aqueous solution plus 2AlOH by 3. It's what? This is aluminum hydroxide 3.
It's good to say that this aluminum hydroxide is the important one. Why? Because we depend on
the reaction here and depend on the solid state here.
It's good, and aluminum cation. Now look at this. White gelatinous PPT of aluminum hydroxide is formed. The formula will be
AlOH by 3. It means what? It means aluminum hydroxide 3.
good. The color here will be
white.
white gelatinous, my dear. Look, soluble this solution in dial acid. This acid solubility in caustic soda. I don't understand this word. Tell me what's the caustic soda.
Caustic soda, it means what? It means NaOH.
It's good to say that. So gelatinous format. Solubility, yeah, can be in presence of acid in caustic soda, sodium hydroxide. What about to fly for this?
Salt solution
Salt solution of what?
of Al.
Depending on what? Aluminium. Aluminium, it has.
It has 3 positive charges here.
Now, complete the equation.
We have the salt solution plus hydroxide. Which hydroxide? We have sodium hydroxide solution. It is the confirmatory test. So the salt solution plus the sodium hydroxide solution give us what?
Give us